Good morning. Hey, Blake and Phil. Okay. Today, ugh, I am, can't talk today. Okay, let's get it right. Today is Friday, the 14th of September, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, and I stream it here on Twitch Monday through Friday. I am working on Basecode. And yeah, after the stream yesterday, this has been happening a lot here, but I've been getting distracted with other stuff. Not stuff I really like to be distracted with, but it happens at times. So, yeah, I really didn't do much, I think, after the stream yesterday. I just committed the changes I had made for the comments on if, else if, and else. I did think a little bit yesterday afternoon while I was waiting for a meeting to start. A little bit about the way block comments are being handled by the parser right now. So, let's see. Yeah. So I have a prefix parser for block comments. I also have an infix parser for it. And I'm kind of thinking I don't want the infix parser anymore. I think the collect comments approach is better. It does mean I'll have to be more explicit about collecting them in a couple spots, but I think that's probably preferable. Excuse me, because I was looking at the code DOM model, and yeah, even though it's technically correct, like the infix block comments are getting associated with the element to the left of them. I think in practice, that's going to be confusing. So it's probably better in the actual, the key parser points to aggregate those, to anchor them to a more, either a statement or, like in the case of if, else, anchor them to one of those parts. Okay, so I expected this. So, not sure which comment is the problem here. So I don't think it has anything to do with the types, because this succeeded. So it's Excuse me. Okay, so now we're down to the if. Oh, maybe. Nope. Yep, we're in the if. Okay, good. All right. Right, okay, so it's in the else if. Okay. We're still missing one. What if the AST nodes were chained horizontally with a linked list besides having parent-child fields? Yeah, so kind of like an R tree or a B star tree, I guess. Yeah, we could do that. I don't know in this case really what that buys me, because I already have lists on the AST node for things. They're kind of, if you wanted to view them as horizontal, you could, I guess, theoretically. Hey, Soding. Okay, so we're here. Man, sorry. Hold on one sec. So we just chewed up this comment. Now we're going to parse the expression. Okay. Then we're going to chew up that comment. All right, so now we're going to parse the block. And okay, so now we're going to look for the else if. First, we should chew up this comment. And let's just make sure this should say before else if. Yep. Then we're going to say, is there an else if? Yes, there is. Okay, we're going to build the else if node. We're going to parse the expression. Then we're going to chew up the comment. Okay, now that's where okay, I see the issue. All right, there we go. Oh, right, okay. Because it's not, yeah, you don't have any infix anymore, so those comments that are after the block, those are just going to sit there unless we chew them up. Yeah. Okay, so that's yeah, this is better. These are all flowing up to the node. All right, so here's the false block. Here's the true block. Excuse me. Yeah, so if we look at AST node, here's a challenge. So what do we have on an AST node? We have an ID, we have a token, we have a type, we have an arbitrary list of children. Right? So these are new. These are denormalizations I recently added. But we always had an arbitrary list of children, right? And we could have an arbitrary list of children, and we could have an arbitrary list of siblings or of just things that apply at this level, right? But here's the thing. Again, if I have this, like I was putting everything in children. If I have another generic collection of nodes that could be any kind of node, then that makes the compiler more complex, right? That makes the evaluator more complex because now I have to actually filter things out. I have to loop through that arbitrary collection of things and say, oh, is it a label thing? Is it a comment thing? Is it an attribute thing? And I was trying to avoid that. I was basically acknowledging that, okay, these are sort of, yes, they're part of the AST, but they're a cross-cutting part of the AST. Everything could potentially have them. So it just made sense to denormalize these lists. And the cost per list, I don't know I'd have to look at what the base cost of a standard vector is. Not that much, 16 bytes, 32 bytes, something like that. So yeah, I mean, I'm maybe burning 64 bytes here. I don't know. If they're empty, obviously, if they have something in them, then that changes. But yeah, sometimes, it makes sense to denormalize, especially in this case where, again, I have in the AST evaluator, I have generic code that's always handling these now. And because I put them in this known spot in the structure, then it makes building that code on the compiler side much, much easier, much faster. I don't have to filter anything. I don't have to apply any conditions. I just look at what's in the list and voila, that's what I have to deal with. That's so good. Hey, Cyanox. Hey, Mr. Kinix.
Yeah, it looks better.
That would explain it. Like, what the heck? So there's the if, there's the else if, and these comments are more closely related to those parts of the tree. So that's good. I like that better, I think, for now. So the downside to that approach is I have to more or less explicitly handle complex comments on a case-by-case basis, but we have a helper function that more or less makes it pretty trivial. And standard, prefix scenarios like this, these are just taken care of, which is fine. So, yeah, I like that better. Let me just test another couple files here. And then we will move on to relational operators. let's review that. So, what did I do? Yesterday afternoon, my mind was wandering and I was thinking about the fact that I had an infix parser configured for comments, and the more I thought about that, the less I liked it, because I put the infix parser here to originally try to address some of these issues with it not parsing block comments everywhere, but now I have a more controlled and very precise mechanism for doing it, so I kind of prefer that approach now. So then in create assignment node, I added a collect comments for the very end, because now we have to manually do that. In the if prefix parser, I have to handle the different cases where we need to collect comments, and we have to make sure that it goes with as close to the nodes that we can contextually. And then in if element, so we only have one, the compiler only knows about if, and the if and else, I think, are the two things that I've got in the compiler. Because else if is really just an if that's related to another if. Actually, I just have if, that's it. Because you can capture everything in that one element. But the parser does have contextual information about whether or not it's an else if. So I'm setting a flag on the if element so we can consult that if we want to know if it was an else if in context. Theoretically, we could figure that out by looking at the parent, and we could consult the model to determine that relationship, but this is a little bit of a shorthand optimization. So I just pass it through the constructor, added an accessor for it. Element builder, we have to pass that flag through now, all the way to the constructor of the if element. Then the code DOM formatter, the name of the if element, I toggle it, right? If it's an else if, I display it as an else if, otherwise it's an if. So, and then in the evaluator, we look at the node type. If it's an else if, then we turn that flag on. Otherwise, we don't. Yeah, and the else expression is really just, it's just a block, essentially. And then I fixed, in the AST builder, it was never setting the else if node type properly. So I fixed that. Excuse me. So that's good. So anyway, yeah, I got to thinking about that, and I'm like, maybe I want to have more control over that. And okay, so that's done. Relational operators. Excuse me. So I guess first, let's go back to if element on emit. Let's make a new test file. Make this really simple. So what I'm looking for first is just, do we get the right labels and do we get the code emitted under the right labels? Then we're going to actually look at the predicate, the relational emit code for that. I had written this once before and it kind of sort of worked, but I was just really not, it was very convoluted on the emit side. Oops. So I gave myself an F. We'll do it again. Okay. Yeah, okay. So if it's true, we're going to call print, passing in the true text, 174, yep. Otherwise, we're going to go to false, but that's the other thing, right? We need to do... Okay, so we get the true block and we execute whatever the code was in that block, and then we jump to the end of the if statement. So we're jumping over the false case. In the false case, if we branch over to the false case because of the predicate, then we'll just fall through to the end. And yeah. Again, there's all sorts of optimizations that could be made for these things, but for now, I just want to try to get the basics to work, and then we can make it smarter. Like, yeah, like I haven't even gone back. One of the very first things I want to do is eventually go back and make all the branches and jumps and everything PC relative, so that the code can all be easily relocatable. But right now, yeah, we'll go back and do that. It should be fairly easy to optimize that. And that'd be a good example of like a first pass optimization on the bytecode. Okay, so I think the structure of the if statement looks correct now. The labels make more sense. It's the name of the if element with its number, a true, a false, and an end. So when we're scanning the assembly output, we can tell really easily where things are going. Yeah, and all we get now is true. Before, we were probably getting true false because it was hitting both blocks. Now we're getting true jumping over the false block, and we're done. All right, predicate. So, binary operator. Net, relational operator. So we should be seeing some code here. Interesting. What is predicate? Should be a binary operator. It's a symbol. Oh, yeah, see? Huh. So, this is funny. I don't have any code to handle implicit booleans. So, I mean, I think on the parser side, this is probably okay. However, the AST evaluator should probably be handling this. So everything is an expression in Basecode. So an if chain, an if ladder, so an if, an else, multiple else if, it's a semicolon because it's an expression. you will eventually be able to do something like that. I mean, you can actually do that now, but this will work more correctly eventually. So. Okay, so first, I should be calling resolve symbol or evaluate because in this case, we want it to be a identifier reference. If it's something like this, but so if it's just an identifier reference, if Okay, so first, we're going to do it with almost what we were doing before. We're going to take that predicate node, whatever it is, we're going to call resolve symbol or evaluate. What resolve symbol does, if it is a symbol, like in this case, it will attempt to look this up and it will make a identifier reference out of it. Otherwise, if it isn't, then it will evaluate it. So if it is a binary expression or a unary expression or whatever, it'll get turned into the right thing. In this case, though, if we just get back an identifier reference, then this is an implicit Boolean operation, right? So we're going to internally translate this to this kind of a deal without the parentheses. So yeah, if it's an identifier reference, we downcast, we infer the type of it. It should be Boolean, right? If it's not Boolean, it can't be, we're not going to implicitly convert numbers or strings or anything into true. There is no, at least for now, I don't intend to do that. That's an error. So, if it's a integer, let's say, you have to explicitly say, is true equal 1 or whatever, however you're interpreting that integer value to be true. But if it is a Boolean type, then we'll just convert that into a binary operator that is doing that comparison for you. Yeah, so then if the type of that identifier is Boolean, we will then convert it for you into an equals binary operator with that identifier reference on the left-hand side and a Boolean true on the right. So let's give that a test. Hey, Magnum Baguette. Okay, so it is an identifier reference. Here's our reference. We're going to infer the type. That should be a Boolean type, which it is. Looks like. Yes. Okay, so then we're going to make a binary operator. Now predicate is a binary operator. Left-hand side is that identifier reference to is true, and the right-hand side is a Boolean literal true. Okay, so now this should emit some code, not all of it, but some of it. Yeah, here we go. So we're going to look up the address of is true, and we're going to load the value into I1, and we're moving the right-hand side into I2, which is 1. So now what's missing is the predicate code. Here. So we got up to this part. So see what that looks like. Okay. So, get the address of is true. We load the value into I1. We load the right-hand side value of the equals binary operator into I2. We compare I1 with I2. If they're equal, then we branch to 140. If they are not, we jump to 180, which is the false. And there you go. And we get true. So then if I change that to false, what do we get? We get, oh no, it's false. It worked. All right. So, again, hugely inefficient, probably can optimize things a lot, but the basics work. So now, All right. So, equals and not equals works for if statements. I just realized that this is insufficient the way I have it written, because what we really have to be able to handle here is if var that is bool. Also, we need to be able to handle like a unary expression of the same kind. Right now, this will slip, although, no, yeah, that'll slip. Yeah, that's Okay. It'll take me a while to use the parentheses. Okay. So what did we get? A is 5. All right, which makes sense. Right. Well, let's look at the code. Okay, so here we go. We're going to load the address of A. We're going to load the value of A. So the binary operator, we have a literal on the right-hand side. So we move that, we compare the value of A to our literal. If it's equal, we go to 3, 3, 4. If it's not equal, we go to 3, 7, 4. 3, 7, 4 is our else if. So 3, 7, 4, we load the address of A, we load the value of A, the right-hand side. If it's less than, we go to 3C4. Otherwise, we jump to 404. And we repeat, this is greater than. Same thing, we come down here. That doesn't look right. That should be BLE, less than or equal. Yeah, that's a bug. BGE. Okay, so this is not generating the correct operand type. Ah, there you go. Wrong token. So let's test that fix. Okay, equal, less than, greater than, less than equal, greater than equal. Yeah, good. Okay, now, so it is printing the first case. Let's make a equal to 4. A is less than 5, 6. And actually, let's do this. Let's break these into their own chain. A is greater than 5, A is greater than or equal to 5. There you go. They all work. Woohoo! But, yeah. Devil's in the details. A is 5, A is greater than or equal to 5. A is less than 5, A is less than or equal to 5. Awesome. All right, so the very simplistic relational operators are working. And as far as that goes, I'm much happier with the way this is implemented than it was last time. However, where it starts to get complicated is a cache override, logical or an and, haven't done those yet, and guaranteed if I try to make a Boolean expression is a less than 5, that's going to not work. So it's interesting. Okay, so we load the address of the variable. We load the address of A, which it didn't resolve. Is that right? No, it didn't resolve it. Yeah. Oh, right, because the labels aren't there. Yeah, anyway, okay. I mean, the only issue is just it's not generating labels. But see, really what we want to do here is we want to use a different set of, we don't want to branch here. At least not in this simplistic case. We want to do a set L here on I0. If there's a logical operator in here, if we had A is less than 5 and is true, that'd be different. Then we need branches, but Hey, Lyle Zombie, how's it going? Okay. I gotta take a really short break. When I come back, we'll review this part, commit it, then I gotta think about how I'm going to do the other bits. I will be back. All right, I'm back. So let's review this part, even though I think I'm going to end up having to rework it a lot, but at least verifies that the interpreter is working. So I created a sample program here in Basecode that kind of tests our if else construct and our very simple relational operators, right? So this doesn't work quite right. Oops, I need to delete it. And I can't use logical and or here yet. But all the different operators that are here now, they do work, and the correct block executes, the control flow is good. I fixed one bug in token. The less than or equal had the wrong token type. And in unary operator, I just did a little bit of cleanup, renamed some things. Hey Slayer Darth. In Lexer, because I was looking at the less than or equal to operator, I took the opportunity to change this to use the match literal helper. Instruction block, I added functions for the other branch instructions that we have. Branch if 0, branch greater, branch less, branch not 0, branch not equal, branch equal, branch greater, branch less than or equal. And BZ and BNZ are really kind of synonyms for BNE and BEQ. And then I refactored, I took what was in BEQ. Oh, I never did, here, let me fix BNE. Make sure that's okay. Okay, this time I got all of them. Refactored all the branch instructions to call make branch, and we passed in the parts that are different for the branch, and then we're good there. On if element for code emit, now the if element takes care of the sequential process of emitting all of its parts. So we create labels for true, false, and end. We emit the predicate. We create the label in the assembler for the true block. We emit the true block. We jump around the false block. We create a label, and if we have a false block, we emit that, and then the final label. And that all looks okay. In binary operator, again, rename some things, clean some stuff up. But then we've got two cases here, but I want to refactor this. I think this needs to be changed the way it's working. But for now, if we are dealing with an if statement, we create the labels, label references for the labels of the if, and then for the different operator types, they all essentially are just branches, right? Because we have one compare instruction, and then it's just based on whatever flags get set, we branch. And then we have to jump around. If the branch is not taken, we have to jump to the false block. And then an EST evaluator, I had to, first, this should have been calling resolve symbol or evaluate. It wasn't, so I fixed that. Partially corrected, so if it's just an identifier reference and that type is a Boolean type, then it gets turned into a binary operator where we're comparing to true. However, for unary operators, I'm going to have to do something there as well. So, yeah, I got to think about that one. And just to test that, so this should generate an error in this case. Which it does. Of course. Yeah, I'm gonna have to think about how I'm gonna do that. Yeah, it's too fragile. So yeah, there's some weak spots. I guess. If it's not a binary operator already, I think that actually works. Because we really don't care what it is. If it has an inferred type of bool, if it's not a binary operator, then we can just assume that we're trying to assert truth. There we go. So, is true is false, not is true is true. So, yeah, oh, but the unary operator probably isn't doing anything. But this worked. So if I set that to 0, yeah, this one's fine now. This. What is that? What code is that generating? It's doing an XOR on it. Why did I do that? Is that what I wanted? So I'm loading the address. If it's true, I'm loading the value into I3. And the value is false, it's 0. So then I'm XORing it, which would set all the, well, it set the lower 8 bits high, which, yeah. Yeah, because that won't compare. Because it's turning all the bits on. Oops. Why did I do it that way? I don't know.
think that's better. Let's take a look.
Okay, so load the address, load the value. We compare the value to 1. It's not 1. So that means the 0 flag would not be set. So set NZ should be setting I1 to 1. Because this is 0. Then we move the right-hand side. We compare. So these should be equal, but they're not. So let's see what the interpreter is doing. Okay, now I'm really confused. It did set it to 1. 1. Okay. Very confused. Ah, shit. I see the issue. Yeah, we're not clearing it. So I2 has got other stuff in it. It's clearing it though. Boolean's not, I bet. Yep. It is not, I bet, doing it. Nope. Yay! There you go. Now it works. Okay. Yeah, there we go. Boom. Okay. That's much better. I don't know why I wrote it the other way. Oh. Okay. So, actually fix that issue. 2 issues. So the unary logical not is now generating bytecode that makes sense instead of what it was doing before. Also, I fixed the issue with if we have a single, we don't have a binary operator in the predicate, then we don't really care what it is, what this expression is, as long as it is a Boolean type. So in this works in this case because I've made it Boolean by casting it. So I just take this, make it the left-hand side of the binary equals expression. So this becomes equal true, right? And same thing, this here is really equal true. That's how that gets evaluated. Same thing here. This is equal true. So that's good. That's fixed. And okay. Yay. See? Always review your code. So, all right. So I fixed that issue, and now I can test this. This works. This works. So the thing I have left is relational expressions and logical operators as a part of that. Yes. Yeah, this is Basecode. So, yeah. All right, so let's look at what I don't think so unary operator, I did change. So what I ended up changing here was logical not. I was XORing, I don't know why I did that. But really what I wanted here, I want to look at the value. If it's 1, then our target is 0. If it's 0, then our target is 1. So I accomplished that by doing a compare and then a set, not 0. And then an instruction block, I had to add an overload to compare that takes a size and a constant right-hand side value. And implemented that. Nothing changed in if. So in the Boolean literal, I was not clearing the target register. So I added that in. Binary operator, I think we looked at this. AST evaluator, yeah. So then the AST evaluator dawned on me that I didn't mean to be so, the only thing I really need to know is, hey, is the predicate a binary operator or not? If it isn't, then I have to determine if the predicate is a binary, or I'm sorry, if it's a Boolean expression, if it infers to a type of bool. If it does, then we're good to go. If it doesn't, that's an error. And then we just make a binary operator equals with the predicate on the left-hand side and a Boolean literal of true on the right-hand side. And that works. Huzzah. I'm pretty happy with that. Is this a programming language you could, oh yeah, is this a predictive parser? I'm a noob, but I got a copy of the compiler book, predictive parser. I don't remember the terminology. Let me look that up. I don't think so. Oh, okay. Yes, I guess the answer to that question would be yes, it is. Although I had forgotten that term, but the parser that I'm actually using a dual parser model. I'm using something called the Pratt parser model plus recursive descent parsers. All right, let me check that in. Okay, so what's left there? What's left there is, and I think what I'm gonna have to do, maybe, I don't know, gotta think about this. I need to support both the relational expression and code flow, control flow. So one way I guess I could rewrite this is I could just assume relational expressions here. So there would be, I would have to generate labels for short circuiting, and this code here would primarily always generate relational expressions, which would then result in a register having a 1 or a 0 in it in the end. And then in the case of an if, then I would just have a little bit of code here that does additional branching for the if case. And then that would seamlessly handle recursive visits from a logical or a logical and. So yeah, I gotta think about that. Because I feel like I can make this much simpler than it is right now. And have it handle both scenarios. So if I can figure that out today, then that's a big chunk fix. Now, there are some things that are not, but this doesn't really have anything to do with if or relational operators per se. This is another part of the compiler, but blocks are not, like, these are not creating scopes the way they should be, right? This is not adjusting the frame pointer. If I had variables in here, they wouldn't be on the stack. So there's issues around the blocks themselves, but again, I have a separate issue for that. That's a separate thing. This is really more about getting the relational expressions to generate the correct code and then the control flow that goes along with it. So I think that part's close, which is really awesome. And so I think that's going to be on my to-do list for today, just to figure that out. And then, yeah. And then with that, with basic relational operators and control flow, even though the scopes are not correct yet from a stack perspective, I can get while working, I could get for loops working. Again, just from a really crude top level, the parser consumes them, generates the right thing in the model generates, roughly speaking, the right code. We can fix the stack frame stuff. Adam Fighter says, do you have any advice for understanding the concepts? They seem so foreign to any programming I've done. Does it get easier? Compiler building, if I just keep at it, I sometimes feel overwhelmed by all the moving parts. I find the grammar the easiest part to understand, but the hardest part to synthesize. Sorry, I keep interrupting you. Not many people around my area know about these things. So first, here's what I would say. I know it can seem very daunting, right? Any big project, I think, really can seem daunting. Two things you always have to remember, right? There is no magic. If you feel like something doesn't make sense, try to narrow it down to the part that isn't making sense, and try to isolate that part of the system as best as you can, and just remember that it is a bunch of small systems working together to yield a final result, right? It's again, I guess, layered design, layered architecture is, you always want to, I think, approach it from that perspective. Don't try to see a compiler as this one big thing. It isn't. It's that's right. So you have some mechanism for getting characters into your tokenizer slash lexer slash scanner, whatever term you want to use, doesn't really matter. And then from there you have tokens, and so you have a parser that consumes tokens and applies the next level up. You know, the lexer slash scanner is very simplistic. It's pulling characters out and saying, hey, this grouping of characters makes this kind of token. And as long as I see tokens roughly in the order that I'm expecting to see them in, then as a lexer slash scanner, I'm happy. And then the parser starts getting tokens, and then it asserts the next level of rules on top of that. And then the parser, I can't speak today, produces then an AST, or whatever model you're using, but probably an AST. And the AST represents the semantic structure of what the parser saw from the tokens, but there's probably going to be some translation there, right? There's going to be some adjustment, and you're probably going to also impute, right, some additional information because you have context. The parser is seeing all these tokens coming together, and that the fact that things are grouped logically in a certain ordering can have informational context, right? So you have to remember that it is, you know, you don't necessarily, I guess what I'm saying is that the fact that the parser sees token A, token B, and token C might mean you get a certain kind of node in your AST. It's not always a one-to-one translation, and it's completely fine to do whatever custom thing you have to do there to produce a model that makes sense for your language. After you have your AST, then there's lots of roads that you can go down. If you go down, like as an example, the Clang model, their front end is intentionally very stupid, generally speaking. It produces an AST, and then that AST is going to be very noisy, is going to have lots of extra information, and then they have, you know, processes that it goes through to fold and optimize that. And then the results of that go to other pipelines that then further, you know, optimize and then eventually convert to their intermediate language, and then from there, eventually you get to native code. But it's a, you know, it's a long process. There's actually several steps going on there, and it's not a bad model to use, to think of it that way. That it's essentially it's just a bunch of transformation steps, right? And eventually you're going to get to a point where you're at the final transformation step, and you have code that's going to run. But there's lots of decisions that you have to make, right? And this is where it gets complicated. Again, this is where it helps to think about the different parts of what you're doing as truly different parts, right? The thing that's going to make native code, if you're going to have a compiler that generates machine code, think of that as a separate thing. You know, if you're going to have byte code, think of that as a separate thing. If you're going to have optimizing steps, you know, think of those as either post or, you know, pre or post processing at different points around those. And you can always fold and optimize things down later. But as an example, you know, in Basecode, I'm doing things in a very specific way because the language kind of dictates that it needs to be that way. As an example, you know, Basecode compiles to its own internal bytecode because the compiler is going to support a very heavy meta-programming system, really full-featured programming system at compile time. Well, really, the most practical way to do that is to, you know, have your code turned into something that can be interpreted at compile time, and then eventually that process will finish. When that's done, inside of the interpreter's heap will be a bunch of bytecode that then another process will take, analyze that bytecode, probably optimize it, and then eventually turn it into native machine code. But if you aren't going to do, you know, compile time metaprogramming like that, then you may not need that step. So there's quite a few forks in the road that you can take. But again, like I was just saying, as you read the Dragon book, as you go through a lot of these things, try to, you know, parsing, which is really multiple steps, that's a part, you know, code generation, control flow analysis, data flow analysis, that's really another part. You know, those things could theoretically be separate programs, and you could, you know, one program could take an input, do some work on it, spew an output, and then the process could just chain like that. Nightbot just went away. Hold on a sec here. There we go. So I don't know. Hopefully that helped. But yeah, don't let it overwhelm you. Just break it down. And of course, like I tell everybody, it's always very helpful to write. You know, just reading books can be very daunting, right? So what I would definitely say is work on one part of the pipeline, right? A lot of people have a hard time with the parsing, right? Like there's a lot of stuff going on there, and it seems really complex, and it is. It's detailed, right? So write a parser, write a lexer, write a parser. Just deal with that part, right? Get up to an AST. Can you define a grammar that's yours? Can you write a lexer and a parser and get an AST out of it? And are you satisfied that that's working? And believe me, like if you go through that process of just writing that part of the chain, even though it's like maybe only a fourth of it, you know, your understanding, I think, is going to increase quite a bit. And it's going to clear a lot of confusion out, I think. And then, of course, you can do prototypes of all the other parts of the system as well. I don't know, a good toy grammar. You could always make a basic. You know, that's always kind of been a long-standing, because basic, and when I say basic here, I don't mean Visual Basic. I mean like old-fashioned Commodore Basic, line number basic, right? There's old-fashioned programming languages like that. They were much more constrained, right? They had quite a few limitations. So that's going to be a lot easier to parse than a more freeform grammar that has a lot more recursion and things going on. Like if you think about Apple Integer Basic, or you think about Commodore Basic, or IBM Basic A, those language, they're just lines, right? So in a way, it's much closer to almost like writing an assembler than it is like a C compiler, but it's a good starting point, right? And if you can get that working, there's enough complexity there that you could build a reasonable AST out of that. And then honestly, like if you did build a, AST for like a basic, again, old-fashioned basic, then it wouldn't take much to go from that to an interpreter, or you could interpret the AST directly, or taking the AST and generating, you could generate Python, or you could generate some other kind of code, right, that would then run that. And that, you don't always have to generate assembly or machine code. You can generate a higher level language to test, that you can transform, one grammar into another grammar and get the semantic, behavior that you're expecting. There are some Lisp. People will tell you, make a Lisp, make a Forth. Here's the only thing I would say about those. Lisp and Forth are so simple on the parsing side of things that Lisp is an AST laid bare in text, essentially. So that's why Lisp can be, the parser part of it can be done so simply. Forth is maybe slightly more complex, but not really excessively so. So those are slightly different scenarios. I mean, you don't end up with as much of a front end. I think it's good to build a Forth or a Lisp just for the fun of it. But those particular examples might confuse you a little bit more because, again, you're going to think, well, where's the AST? Where's this? Where's that? And in those, you just really don't need as much complexity because of the nature of the languages. So, maybe special case those a little bit in your mind. But yeah, that's what I would do. That's where I would start. Yeah, like I say again, Lisp is great because Lisp is, hey, why do we need to bother with parsing? Let's just take the AST and make it the thing that you have to type in, more or less. And again, like Forth is very similar. Like Forth is an RPN calculator, essentially, and Lisp is, a prefix. It's the opposite, right? It's prefix based. Or actually, no, I take that back. No, it's opposite. Because in Forth, it would be 5 plus 2 times. Yeah, it would be the opposite, right? Lisp is the other way around. But it's the same idea inverted, right? So, and again, I think there's a lot of cool stuff to learn there, but it's just a different environment. Yes. But you want to be comfortable with stacks and definitely want to, make sure you understand. Again, the other side of writing compilers and interpreters, I guess, is that ideally, if you're uncomfortable with how the machine actually works, that can add to confusion, right? So what I always tell people is, if you don't have any experience with like assembly language or understanding what the CPU is and does, because ultimately that's what you're targeting when you're building an interpreter or a compiler, you really do need to kind of understand what the low-level fundamentals are there, because otherwise it's going to feel like there's stuff missing, especially as you get closer and closer to like the code generation side of things. I would hold off, doing any kind of just-in-time compilation or anything like that until you've done several ahead of time projects. Because just-in-time compilation can add some additional complexity to everything. Shadow Demon 58 asks, what programming books do you recommend that are great to get as good as you are programming? I'm very contrarian here. I know books are, I'm not saying that books don't have value, but I'm going to be honest, right? Like, I have yet in my life read any book that told me how to do everything, right? Like there's no one and done. It's accreting knowledge, right? As you go along, knowledge. And again, ultimately, when it comes to programming, you have to do it, right? You have to write code. Doing it all in your head, like, you would be amazed at the wonders you can generate in your brain. And then as soon as you think you're going to build that, like, all sorts of stuff starts to break and you realize that none of it makes sense. Which is why it's much better to kind of tether yourself to having to build the code all the time, having to write code all the time, and read books, read a variety of books. Just understand that any one book you read is just another plank that you add to your accumulated knowledge base. Or the book makes you, maybe the book doesn't give you anything new per se. Maybe the book just makes you think in a different way for a short while, and that in and of itself has intrinsic value. So what I would say is, instead of recommending specific titles, I always tell people this: avoid books that are about tools, unless the only exception I would put there is if it's for your job and you need to bone up for an interview or something specifically about a tool. Fine, go to the library and get, rent some, or borrow the book long enough that you can pass the test or get the few little tidbits of trivia that you need. But for programming, avoid books that have Visual Studio in the title, or Eclipse in the title, or whatever, right? Those are not going to be helpful for you. Avoid books that have 30 days or 20 days or 15 days in the title. In general, I would just avoid those. So then that leaves you with, all the other books, and, those, you just kind of work through those as you come to them. And if there's a particular, like I was saying about the compiler stuff, making a language, you're going to have questions, right? So as questions come up, make notes. If you don't have material, or you can't easily find it on, the interwebs, then, do a search for books that you think will help you in that topic space. But like I always say to everybody who asks, the number one thing you can do to improve your programming skill set is allocate at least an hour per day, preferably the same hour, meaning at the same time every day, if you can manage it. And during that hour, you're not reading books, you're not surfing the web, you're not playing games on your phone, you're not watching YouTube and all the neat, happy kittens. You're you're actually writing code and have a project in mind, whether you're making a programming language, you're making a compiler, or you're making a game, or whatever you're making. And during that hour, you work on that project. And an hour is really kind of the minimum in my mind. The more you can allocate to that process, the better off you'll be. Up to, I would say, 5 or 6 hours. Much beyond that, I think there's huge diminishing returns in programming. Everybody varies, but as a rule of thumb, yeah, that's gonna get you the most mileage. And then in that model, I see books and videos and blog posts and all that stuff at mentors. Those are things that you pull as you need them, right? It's not a top-down thing. It's not, I need knowledge, find books, read books, then practice. No, it's every day practice, pull what you need to be able to accomplish your goals. So it's more on demand. And avoid Ty Lopez and Gary Vaynerchuk. Yes, avoid books about tools, as in those in the shed, and avoid books about tools, as those who bike shed. Oh, Gary Vaynerchuk, the guy who was a millionaire before he was a millionaire. All right, any other questions? Shoot. Yeah. Term info is a structure. No. I mean, again, from scratch here, at some point, you're going to probably, being pragmatic, you're going to use existing libraries, you're going to use existing tech. So, yeah, I mean, if you're at the point where you're writing something like in C or C++ and you're doing it in the terminal, ncurses would be the way to go. And term info is just, it's just data that the terminal gives back that tells you what it supports, right? Because you gotta remember, terminals are ancient. So a lot of, what you see in a terminal is it's emulating stuff that was designed many, many decades ago, and which is kind of silly when you get down to it, but it works, and there's a ton of legacy, and it's difficult to get around all that stuff. So, yeah, so like I say, if you're at the point where you've already written a snake game in like something like Easy 68K or whatever, an assembly language, which is, it's an all-in-one environment. You don't have to go anywhere else. You don't have to use libraries or anything. It's built in. But if you're at the point of doing that in like C or C++ and you're, doing it, once you get into that realm, unless you specifically want to go down the path of trying to doing it on bare metal or, using QEMU or something to, build it virtually from scratch, yeah, you're going to use libraries, and yeah, just use the libraries that make sense. I also love how people tell you to only do stuff you want to do, but sometimes you'll just have to bite through it in order to improve yourself and get to the solution. I agree. The thing I would say though is when you're learning, I do tell people pick projects that are going to keep you motivated, right? Don't try to build something that you really don't want to build. I mean, that seems obvious, I guess, but it's going to be much more difficult to stick with something if you dread it. So now within that, though, I do agree that you're going to hit parts of the process, no matter what you're building, that you're not going to necessarily enjoy or going to be challenging. And yeah, you have to push through those. You have to work on that stuff. Magnet Baguette has another question. I have a problem. Where do I run my assembly code for 8085? I mean, the kit I use has 7-segment LED. Yeah, I mean, this is where things get challenging, right? I haven't looked in a long time if there's an 8085 simulator out there. I mean, keep in mind that the 8085 it's a Z80 with additional I/O. There are probably plenty of classical Z80 simulation environments. I haven't looked in a long time. So that's certainly an option. You could look around and see if there's something for that. I will admit, though, that the number of, if you have a very specific, ISA, CPU target in mind, it can be difficult to find, tools. So but yeah, you're probably going to have to find an emulator. Most definitely. Of some kind. I mean, it's either that, or if you're studying electrical engineering, you could also, of course, wire wrap a more complex 8085. You could wire wrap or breadboard, honestly, a more complex 8085 setup, but that's, you know, that's assuming that you're doing the electrical stuff, electrical engineering stuff as well. If not, if you're just doing it for programming, then I would say your best bet is probably an emulator. You know, again, I haven't specifically, yeah, there's a CPM. So that's the other thing, right? Yeah, here's a bunch of Z80 stuff. So so yeah, if you Google, you can find stuff. I don't know how good it is, but I ordered a bunch of perf board a while back. I haven't had the need to order any more recently. But yeah, if you go to, I would imagine, like, you know, Mouse or DigiKey, they should have, you know, perf board available. However, I've been seeing on Twitter, I follow a bunch of guys that are in the electrical engineering space, and evidently there is a component shortage right now, so I don't know if that includes things like perf board. Anybody have any suggestions for who I should raid today? All right, let's raid Mackel Yan. Everybody have a good weekend. I should be back online on Monday, and we'll pick up wherever I leave off. Have a good one. Say hi here. Have a good one. Bye.